Have you ever imagined humans living on Mars, the Moon, or even asteroids? In this video, we'll explore 100 mind-blowing facts about space colonies and the future of mankind. From floating cities to growing food in space, these facts show how science, technology, and human ingenuity could make life beyond Earth a reality. Let's take off and see what the future holds. Chapter 1. Imagine living on Mars, where the sky isn't blue, but a dusty orange. Scientists say future colonies will use giant domes to create Earth-like air. You could walk outside only in protective suits, while robots build homes around you. Water will be recycled endlessly, food grown in soil-free greenhouses. Humanity may finally live beyond Earth, learning to adapt to alien worlds. Chapter 2. Space colonies might orbit Earth first, like floating cities. Solar panels will power them, capturing sunlight constantly. Residents will feel lighter gravity, making every jump a small thrill. Scientists predict these orbital homes could house thousands, with labs, farms, and even schools. Life in orbit will be a mix of high-tech survival and everyday human routines. Floating cities could be the first step to the stars. Chapter 3. Mars dust storms are massive, sometimes covering the entire planet for weeks. Colonists will need underground shelters or heavily reinforced domes. Engineers are already designing systems to clean air and shield against radiation. Every meal, water drop, and bit of oxygen must be managed carefully. Life on Mars will test human resilience like never before, forcing us to become both explorers and scientists daily. Chapter 4. Moon bases may be simpler than Mars colonies because of shorter travel time. Lunar colonies could mine helium-3, a rare element for clean fusion energy. The low gravity will allow new kinds of architecture and sports. Spacesuits will be less bulky for daily tasks. Even with extreme conditions, humans will find ways to work, play, and survive. Proving adaptability is our strongest trait. Chapter 5. Asteroids may become miniature colonies or mining hubs. These small rocks contain precious metals and water. Colonists could harvest resources while orbiting the sun. Tiny habitats might rotate to create artificial gravity. Science fiction is becoming reality as robots pave the way and humans follow. Mining asteroids could fund larger space projects, making exploration both profitable and practical. Chapter 6. Self-sustaining ecosystems are crucial for space colonies. Scientists call them closed-loop life support. Every drop of water, every plant, every bit of air is recycled. Algae may generate oxygen. Insects feed on waste, humans eat the rest. It's a delicate balance of biology and technology. Life in space teaches us how fragile Earth's systems are, and how carefully we must manage them elsewhere. Chapter 7. Gravity is a major challenge in space colonies. Too little and bones weaken, muscles shrink. Engineers may rotate habitats to simulate Earth gravity. Astronauts already exercise hours daily to prevent deterioration. Future colonists will rely on both technology and lifestyle adjustments. Space science is not just about rockets. It's about shaping human bodies to survive where nature didn't design us to live. Chapter 8. Radiation is a silent danger. Cosmic rays can damage DNA, increase cancer risk. Mars and Moon colonies will need shielding, water walls, regolith layers, or magnetic fields. Robots may help build these defenses before humans arrive. Daily life in space will include monitoring radiation and smart scheduling of outdoor activities. Surviving in space is a science of anticipation, prevention, and constant vigilance. Chapter 9. Food in space colonies isn't just survival, it's science and creativity. Hydroponics and aeroponics grow vegetables without soil. Scientists experiment with 3D printed food and lab-grown meat. Colonists may taste flavors they never imagined, while nutrition is carefully calculated. Every meal is a mix of biology, chemistry, and engineering. Space colonies will redefine the relationship between humans and the food we eat. Chapter 10. Energy in space comes almost entirely from the sun. Solar farms in orbit or on the moon could power entire colonies. Excess energy might even be sent to Earth. Batteries, superconductors, and smart grids manage constant supply. Colonists will learn to optimize every watt, making energy precious and sustainable. Harnessing the sun is the backbone of life beyond Earth, a science that is both ancient and futuristic. Chapter 11. Water is the most precious resource in space. Colonies will recycle urine, sweat, and even condensation. Ice from asteroids or polar regions of the moon may be melted for drinking. Every drop counts, teaching humans efficiency on a scale never needed on Earth. Water management will be the lifeline of space colonies, blending engineering, chemistry, and human discipline into daily survival. Chapter 12. Communication across planets isn't instant. Signals to Mars take minutes, creating natural delays. Colonists must plan carefully and make decisions independently. Advanced AI and automation will assist, but humans remain critical. Space teaches patience and foresight. Life on distant worlds won't be like Earth. It's a continuous challenge of timing, planning, and trusting both machines and human judgment. Chapter 13. Sleep cycles may be tricky in space. Without natural day-night patterns, circadian rhythms shift. Colonists might use artificial lighting mimicking sunlight. Science shows consistent sleep is crucial for mental and physical health. Colonists will track cycles carefully using both biology and technology. Space life forces humans to master their own bodies in ways Earth never demanded, blending science and personal discipline. Chapter 14. Terraforming is a dream for distant planets. Scientists study how to warm planets, thicken atmospheres, and even introduce microbes. Mars may be the first candidate, slowly transforming into a livable world over centuries. Colonists will witness early steps: greenhouses, oxygen generators, and soil enrichment. Terraforming blends imagination with hard science, showing humanity's ambition to become a truly interplanetary species. Chapter 15. Robots will build the first structures before humans arrive. Autonomous machines can work in dangerous environments, stacking modules, mining, and assembling equipment. Colonists then take over, turning bare habitats into homes. Humans and robots will coexist, each doing what they do best. Space colonies will demonstrate collaboration on a scale impossible on Earth, blending technology with human ingenuity. Chapter 16. Space travel alters perception of Earth. From orbit or Mars, Earth looks like a fragile blue dot. Colonists report heightened awareness of environmental fragility. This perspective inspires better care for our home planet. Science and space exploration are not just about reaching new worlds. They change how humans think, feel, and act, connecting cosmic knowledge with everyday responsibility. Chapter 17. artificial gravity may shape space habitats. Rotating cylinders or tethers simulate Earth-like pull, preventing muscle loss and bone decay. Engineers calculate rotation speed, radius, and structure carefully. Humans adapt physically and psychologically. Science meets architecture to create livable environments far from Earth. Every step taken in artificial gravity will test ingenuity, safety, and human adaptability. Chapter 18. Psychology is critical in isolated colonies. Long-term confinement can trigger stress, anxiety, and conflict. Crew selection, communication, and entertainment systems become essential. Social dynamics are studied scientifically, influencing habitat design and routines. Colonists learn to live together under extreme conditions, revealing the human mind's flexibility and resilience, and the importance of mental health in pioneering new worlds. Chapter 19. Energy storage will define colony survival. Solar power peaks may not match demand. Batteries, flywheels, and supercapacitors store energy for dark periods. Science ensures no interruption in oxygen, water, or life support. Colonists become masters of energy management, balancing supply and demand precisely. Power becomes a tangible measure of survival, turning physics into daily strategy. Chapter 20. Space medicine evolves rapidly. Microgravity affects bones, muscles, and organs. Colonists will monitor health constantly, using wearable devices and AI diagnostics. Medical research in space may cure Earth diseases. Science and healthcare merge, ensuring humans can survive, adapt, and thrive far from Earth. Space colonies become living laboratories, combining exploration, survival, and medical breakthroughs. Chapter 21. Spacesuits are more than clothing, they're life support systems. They supply oxygen, regulate temperature, and shield from radiation. Every joint, helmet, and glove is engineered for survival. Colonists will rely on suits to explore Mars, the Moon, or asteroids safely. Each suit becomes a personal ecosystem, a perfect mix of science and human ingenuity, keeping explorers alive in alien environments. Chapter 22. Dust is a hidden enemy on Mars. Fine particles infiltrate equipment, habitats, and even. Chapter 23. Space farming experiments show plants grow differently in low gravity. Roots, stems, and water behave strangely, requiring innovative systems. Colonists use hydroponics, aeroponics, and LED lighting to grow crops. Success means nutrition, morale, and independence. Science becomes storytelling as green shoots emerge from alien soil. Growing food in space is a daily lesson in biology, engineering, and hope. Chapter 24. Space colonies may eventually recycle air using algae or bacteria. Photosynthesis becomes a life-saving tool. Every breath counts, and oxygen is precious. Colonists learn to manage life support with precision. Small mistakes can be critical. Science here is both visible and invisible, showing how tiny organisms can support human survival on worlds far from Earth. Chapter 25. Terraforming experiments teach patience. Introducing microbes to soil, warming surfaces, and releasing greenhouse gases could make Mars more Earth-like. Colonists witness slow transformations, sometimes barely noticeable. Science progresses in centuries, not days. Every small success is a lesson in perseverance and planning. Humanity's reach extends across planets, proving ambition paired with methodical science can reshape worlds. Chapter 26. Artificial intelligence will manage much of daily life. AI schedules tasks, monitors systems, and predicts failures. Colonists rely on it, but humans remain decision makers. Trust between humans and machines becomes essential. Science meets practical problem solving, showing how technology can extend human capability. Life in space will blend human intuition with machine precision to survive and thrive. Chapter 27. Space habitats may rotate to create gravity. Calculations must be precise. Too fast, and people get dizzy. Too slow, and bones weaken. Physics becomes daily reality. Colonists learn to move, exercise, and live in these conditions. Every rotation teaches about balance, engineering, and human adaptation. Artificial gravity transforms science into tangible, lived experience. Chapter 28. Solar flares pose real threats to space colonies. High-energy particles can damage electronics and harm humans. Shielding, early warning systems, and emergency protocols protect life. Colonists become vigilant, learning to read the sun's signals. Space teaches constant respect for natural forces. Living beyond Earth is a mix of excitement, discipline, and scientific awareness. Chapter 29. Water harvesting from lunar ice is feasible. Colonists could extract frozen deposits near the moon's poles. Every liter counts. Science, engineering, and resource management intersect. Water supports drinking, farming, and oxygen production. Each mission demonstrates efficiency, planning, and human ingenuity. Life on the moon becomes a careful balance between resource availability and survival strategy. Chapter 30. Magnetic fields could protect colonies from radiation. Experiments suggest artificial shields may replicate Earth's natural defense. Engineers plan habitats inside magnetic domes or tunnels. Colonists could walk safely outside during solar storms. Science shows protection is possible, but requires constant monitoring. Space life depends on understanding invisible forces, turning physics into practical solutions for survival. Chapter 31. Space radiation affects not just health, but electronics. Chips can fail, computers crash, and instruments degrade. Colonists rely on radiation-hardened technology and redundancy. Every system has backups, and engineers plan for worst-case scenarios. Science here is survival, blending physics, materials, and human ingenuity. Living in space demands respect for forces invisible yet powerful. Chapter 32. In microgravity, liquids behave strangely. Water forms spheres, fuel floats, and food sources drift. Colonists must adapt daily routines. Cups, pipes, and containers are engineered carefully. Every spill is a lesson in physics. Life in low gravity turns ordinary tasks into science experiments, making humans both explorers and constant problem solvers. Chapter 33. Asteroid mining could fund future colonies. Metals like platinum, nickel, and gold are abundant in space rocks. Small automated missions can extract resources safely. Colonists monitor operations from orbit or habitats. Science and economy merge, turning exploration into practical sustainability. Mining asteroids proves humans can use knowledge for both survival and profit in space. Chapter 34. Microbes in space behave differently. Some grow faster, others weaker. Colonists must monitor bacteria closely to prevent contamination. Science experiments study these changes to protect human health. Space life is a mix of biology and vigilance. Understanding tiny organisms becomes critical when every system, from food to air, depends on balance. Chapter 35. Space tourism is a preview of future colonies. Short trips teach us about zero gravity, radiation exposure, and isolation. Companies design habitats and spacesuits for civilians. Science and entertainment combine, making space accessible and practical. Early tourism missions provide data for long-term survival, proving even short experiences can prepare humans for interplanetary living. Chapter 36. Hydroponic gardens could provide fresh food and oxygen. Nutrients dissolved in water feed plants efficiently. Colonists monitor growth, adjusting lighting and temperature. Every harvest is a lesson in biology, chemistry, and sustainability. Science becomes daily routine, transforming food production into both survival and wonder, showing life beyond Earth can thrive with careful planning. Chapter 37. Mars dust contains toxic chemicals like perchlorates. Colonists must clean soil before growing food. Experiments test water filtration, soil treatments, and robotic cleaning. Science ensures safety and health. Living on Mars means understanding the dangers beneath your feet and transforming harsh conditions into sustainable living. Knowledge and caution become survival tools. Chapter 38. Spacesuits may one day be smart devices. Sensors track health, temperature, and oxygen. AI could assist with navigation and alerts. Colonists rely on suits as life support and data hubs. Science turns clothing into technology, making humans safer and more informed in alien environments. Every step outside is a combination of exploration and engineering. Chapter 39. Energy storage in space may include nuclear reactors. Small, safe reactors could provide constant power when solar fails. Colonists monitor systems closely. Science ensures stability, efficiency, and safety. Reliable energy is crucial for life support, research, and industry. Space colonies will prove humans can harness powerful energy sources responsibly far from Earth. Chapter 40. Artificial intelligence may teach colonists skills in real time. From engineering fixes to medical procedures, AI provides guidance. Humans remain in control, but gain enhanced capabilities. Science and technology merge to make space survival feasible. Life in colonies becomes a partnership with machines, blending knowledge, adaptability, and human curiosity. Chapter 41. The moon's low gravity allows unique construction methods. Colonists could 3D print homes using lunar soil. Layers of regolith act as insulation and radiation shield. Science and engineering combine to make habitats safe and efficient. Every building project teaches adaptability and resourcefulness. Life on the moon merges creativity with survival, proving humans can thrive in extreme conditions. Chapter 42. Mars rovers are the first settlers before humans arrive. They map terrain, test soil, and scout water sources. Colonists rely on their data to plan habitats. Robots work tirelessly, often far from human supervision. Science shows machines can prepare the way for humanity. Space exploration becomes a partnership between human curiosity and robotic endurance. Chapter 43. Solar storms can temporarily disable satellites. Colonies need backup communication systems and shielding. Scientists monitor the sun continuously. Colonists plan activities around potential hazards. Space life teaches anticipation and caution. Science and daily life intersect, proving that survival depends on understanding forces far beyond our control. Chapter 44. Colonists may grow genetically modified crops for space. Plants adapted to low light, low gravity, or limited water maximize yield. Science ensures nutrition and sustainability. Food becomes a combination of biology, technology, and planning. Space farming is not just survival. It's innovation, turning tiny green shoots into hope for humanity beyond Earth. Chapter 45. Mars' thin atmosphere provides minimal protection from meteors. Habitats require reinforced structures and early warning systems. Colonists monitor impact risk constantly. Science ensures safety and long-term survival. Living under constant threat teaches adaptability and careful engineering. Every day is a reminder that space exploration combines excitement with vigilance. Chapter 46. Waste management is crucial in closed-loop habitats. Every drop of water, food scrap, and human waste is recycled. Engineers design systems to prevent contamination. Colonists learn efficiency, precision, and responsibility. Science turns necessity into art, showing that survival beyond Earth depends on mastering even the smallest details. Chapter 47. Space elevators may one day reduce travel costs. Using strong materials like carbon nanotubes, cables could connect Earth to orbit. Colonists could transport goods and people efficiently. Science turns physics into practical infrastructure. Future colonies rely on bold ideas, proving that imagination combined with engineering can reshape space travel. Chapter 48. Microgravity affects human development. Children born in space may grow differently, with altered bones and muscles. Science studies these effects carefully. Colonists prepare for long-term habitation, ensuring safety and health for all ages. Space life challenges biology, demanding careful adaptation for future generations. Chapter 49. Lunar caves may become natural shelters. They protect from radiation, extreme temperatures, and micrometeorites. Colonists explore these formations for homes or storage. Science merges geology and engineering, using nature itself to aid survival. Living in these caves blends adventure with practicality, showing how humans can adapt to alien landscapes. Chapter 50. Energy transfer between planets may be possible with space-based solar arrays. Collected power could be sent via microwaves to distant colonies. Science transforms sunlight into lifelines across the solar system. Colonists will manage energy with precision, proving that technology can bridge distances that once seemed impossible, powering humanity's expansion beyond Earth. Chapter 51. Space debris is a growing threat in Earth orbit. Tiny fragments travel at incredible speeds, risking habitats and satellites. Colonists will track debris constantly and rely on shields or deflection systems. Science and technology work together to prevent disasters. Living among the stars requires vigilance, reminding humans that even tiny objects can have huge consequences in space. Chapter 52. Martian dust contains chemicals that can affect humans. Colonists must wear protective suits outdoors and clean soil for farming. Science ensures safety through filtration and decontamination systems. Every step outside teaches caution. life on Mars blends exploration with risk management, showing that survival beyond Earth depends on preparation, knowledge, and careful planning. Chapter 53. Artificial intelligence will optimize energy use in colonies. It predicts peaks, adjusts systems, and prevents waste. Humans remain in charge but benefit from AI efficiency. Science turns computation into survival strategy. Every watt counts, making energy management a critical daily task for life beyond Earth, blending technology with human decision-making. Chapter 54. Space habitats may rotate to simulate gravity. But motion sickness is common initially. Colonists adapt gradually, learning new ways to move, exercise, and work. Physics becomes personal as every action feels different. Science helps design rotation speed, radius, and layout to balance comfort and health. Living in artificial gravity turns survival into constant adaptation. Chapter 55. Colonists may explore ice caves on Mars. Ice contains water and preserves ancient secrets. Robots scout while humans study geology and potential resources. Science combines exploration, survival, and discovery. Every frozen chamber teaches about history, resource management, and the adaptability required to live on another planet. Ice becomes both shelter and treasure. Chapter 56. Space medicine will be advanced and remote. AI-assisted diagnostics monitor vital signs, predict illness, and guide treatments. Colonists learn to perform procedures with precision. Science ensures health far from Earth. Every medical checkup is both practical and experimental, blending human care with technology in ways impossible on Earth. Chapter 57. Colonists may rely on 3D printed tools and spare parts. Printing reduces dependency on Earth shipments. Engineers design multi-material printers for metals, plastics, and composites. Science turns manufacturing into survival. Life in space demands creativity, foresight, and efficiency. Every printed component proves humans can adapt production to alien worlds. Chapter 58. Radiation storms from the sun are unpredictable. Colonists monitor solar activity continuously. Emergency shelters and protocols protect humans and electronics. Science transforms awareness into defense. Living in space teaches respect for cosmic forces. Safety relies on both technology and human vigilance, making survival a blend of planning, science, and adaptability. Chapter 59. Low-gravity sports may become common in colonies. Jumping higher, spinning, and floating create new forms of exercise and fun. Science studies physical effects to prevent injuries. Recreation boosts morale, mental health, and teamwork. Space life combines survival with innovation, showing humans can adapt their bodies and culture to extraordinary environments. Chapter 60. Colonists will develop sustainable water systems. Recycling urine, capturing condensation, and extracting ice are essential. Engineers optimize every drop. Science and careful planning ensure survival. Water becomes a currency of life, teaching efficiency, responsibility, and respect for resources in alien worlds. Every sip is a victory for human ingenuity and adaptation. Chapter 61. Space habitats will need reliable air systems. Oxygen generation, CO2 removal, and pressure control are vital. Colonists monitor sensors constantly. Science and engineering ensure breathable air. Every breath depends on technology and human diligence. Living in space teaches appreciation for simple things like air and shows how survival relies on precise systems working perfectly in alien environments. Chapter 62. Mars rovers are scouting for ice beneath the surface. Detecting water guides habitat placement and farming. Robots map terrain and relay data back to humans. Science turns remote sensing into survival. Every exploration mission increases safety, knowledge, and confidence. Colonists rely on machines to prepare the way, blending curiosity with practicality in harsh, distant landscapes. Chapter 63. Low gravity alters human muscles and bones. Daily exercise is essential to maintain health. Machines and resistance training simulate weight. Science and discipline protect the body. Every hour of exercise is preparation for survival and exploration. Space life demands humans understand and adapt their own biology, turning physical care into a key aspect of interplanetary living. Chapter 64. Solar panels will cover space colonies like giant sails. They capture sunlight for electricity continuously. Chapter 65. Robotic assistants will handle dangerous tasks. Mining, assembly, and repairs may occur without human presence. Colonists supervise remotely. Science transforms labor into safe, efficient operations. Robots expand human reach and reduce risk. Life on other planets becomes a partnership, blending human strategy with machine endurance. Every mission is a balance between curiosity, technology, and survival. Chapter 66. Radiation shielding may use water, soil, or specialized materials. Habitats are built with layered protection. Colonists track exposure constantly. Science ensures both safety and long-term health. Living under invisible threats demands vigilance, planning, and respect for physics. Every shielded wall becomes a lifeline, demonstrating how humans turn knowledge into practical defense. Chapter 67. Space colonies may include laboratories for experiments impossible on Earth. Microgravity allows new discoveries in physics, biology, and materials science. Colonists participate in research while surviving daily challenges. Science and survival merge. Every experiment contributes to knowledge and life support solutions, proving that exploration and discovery are inseparable from interplanetary habitation. Chapter 68. Food will be grown efficiently in hydroponics or aeroponics. Nutrients, water, and light are optimized for growth. Colonists monitor plants closely. Science and careful planning ensure nutrition and sustainability. Growing food in space turns biology into a survival tool. Every harvest is proof that humans can create life-supporting ecosystems beyond Earth. Chapter 69. Space communication networks will be advanced. Satellites relay signals across planets, allowing humans to stay connected. Colonists manage delays caused by distance. Science transforms speed of light limitations into practical systems. Every message becomes a reminder of both isolation and connection, teaching patience and ingenuity while maintaining human contact across the solar system. Chapter 70. Artificial intelligence will predict maintenance needs in habitats. Sensors detect wear, energy demand, and environmental changes. Colonists rely on AI alerts to prevent failures. Science turns data into life-saving decisions. Life in colonies requires trust, observation, and technology. every prediction improves safety, efficiency, and adaptability in environments where mistakes can be fatal. Chapter 71. Meteorites constantly bombard planets and moons. Colonists monitor impacts and reinforce habitats. Science predicts trajectories and minimizes risk. Living under constant threat teaches preparation and engineering. Every shielded wall and early warning system is a lifeline. Space life combines vigilance with curiosity, reminding humans that survival beyond Earth demands respect for forces far greater than ourselves. Chapter 72. Gravity affects fluid distribution inside the body. Colonists experience swelling in the head, lower body muscle loss, and changes in heart function. Science monitors these effects. Exercise, diet, and routines adapt the body to low gravity. Every day is a lesson in physiology, proving humans can modify behavior and habits to survive beyond Earth. Chapter 73. Artificial lighting mimics day-night cycles in space. Circadian rhythms are critical for health, sleep, and mood. Colonists use timers, LEDs, and environmental controls to maintain natural patterns. Science ensures humans remain alert and healthy. Every sunrise in space is a combination of biology, technology, and survival strategy. Chapter 74. Space colonies may mine rare elements from asteroids. Platinum, gold, and other metals support technology and economy. Robots perform risky tasks while humans supervise. Science turns exploration into practical benefit. Every asteroid mission combines survival, resource management, and curiosity, proving humans can turn knowledge into wealth in alien environments. Chapter 75. Radiation affects not only health but electronics. Colonists rely on hardened devices, backups, and redundancy. Science ensures operations continue even during storms. Every system has a contingency plan. Space life merges technology, physics, and vigilance, showing that survival depends on both preparation and understanding invisible dangers. Chapter 76. Hydroponic farms recycle water and nutrients efficiently. Colonists grow vegetables, fruits, and plants, and even herbs. Science ensures food quality and sustainability. Every harvest is proof humans can create life-supporting ecosystems beyond Earth. Farming becomes both science and survival, blending biology with engineering and hope for future generations. Chapter 77. Mars dust storms are massive and persistent. Habitats must be sealed, robots protected, and air filtered. Colonists adapt schedules and routines around these events. Science ensures safety and functionality. Every storm teaches humans to respect the environment and plan for conditions far beyond anything on Earth. Survival depends on preparation and adaptability. Chapter 78. AI-assisted medical monitoring becomes essential. Wearables track vitals, predict illness, and guide treatments. Colonists can perform procedures with AI support. Science ensures health in isolated environments. Every checkup combines technology and human skill, making survival possible where Earth-based healthcare is unavailable. Chapter 79. Space debris poses constant danger to satellites and habitats. Tracking systems, shields, and evasive maneuvers protect colonies. Science transforms observation into defense. Every orbiting object becomes a potential hazard, teaching vigilance, planning, and precision. Life beyond Earth requires humans to respect even the smallest objects in high-speed space environments. Chapter 80. Artificial gravity may rotate habitats like cylinders or rings. Colonists adapt to motion and exercise routines. Physics affects every movement, from walking to using equipment. Science designs rotation speed and structure for comfort and health. Every rotation demonstrates human adaptability, turning physics into practical survival in alien environments. Chapter 81. Water in space is recycled endlessly. Every drop from sweat, condensation, and urine is purified. Colonists rely on these systems for survival. Science ensures water remains safe and drinkable. Every sip is proof of human ingenuity. Life beyond Earth turns necessity into technology, making careful management of this resource a daily habit and a lesson in efficiency. Chapter 82. Spacesuits will evolve into smart systems. Sensors track oxygen, temperature, and health. AI assists navigation and safety alerts. Colonists depend on suits for survival. Science combines biology and technology. Every venture outside a habitat becomes both exploration and a technological partnership, proving humans can extend their capabilities far beyond natural limits. Chapter 83. Mars habitats may use underground tunnels. These provide radiation protection, stable temperatures, and meteorite safety. Colonists explore and build carefully. Science and engineering merge to create secure living spaces. Every excavation shows adaptation and creativity. Life underground teaches humans to utilize natural features for survival while blending innovation with environmental awareness. Chapter 84. Energy from solar panels must be stored efficiently. Batteries, supercapacitors, and smart grids ensure constant power. Colonists monitor usage and prevent waste. Science and planning maintain life support systems. Every stored joule is critical. Energy becomes a tangible measure of survival, transforming physics into practical daily strategy for life beyond Earth. Chapter 85. Asteroid mining may supply water, metals, and fuel. Automated systems extract resources while humans supervise remotely. Science turns space rocks into usable materials. Every mission combines economy, survival, and exploration. Colonists learn that resource management in space is a mix of technology, planning, and human ingenuity, laying the foundation for sustainable expansion. Chapter 86. Space radiation can mutate microbes. Colonists monitor bacterial growth closely to prevent contamination. Science ensures safety in food, water, and medical systems. Every experiment provides lessons in adaptation and vigilance. Life in space requires understanding biology in new ways, turning tiny organisms into both threats and tools for survival. Chapter 87. Low gravity alters fluid behavior. Water, fuels, and blood move unpredictably. Colonists must adapt routines and containers. Science transforms daily life into constant experimentation. Every spilled drop is a reminder that physics changes in space, making even simple tasks an opportunity to learn, adapt, and survive. Chapter 88. Terraforming Mars is slow but possible. Microbes, greenhouses, and atmospheric modification may gradually make it habitable. Colonists witness early changes and contribute to experiments. Science blends patience, innovation, and ambition. Every small success proves humans can reshape environments far beyond Earth, combining exploration with methodical experimentation. Chapter 89. Robotic assistants reduce human labor. Machines assemble habitats, mine resources, and handle dangerous tasks. Colonists supervise and maintain. Science turns automation into survival. Every robotic action saves lives and time, showing that human ingenuity is amplified when combined with advanced technology in harsh environments. Chapter 90. Food systems rely on controlled environments. Hydroponics, aeroponics, and lab-grown proteins ensure nutrition. Colonists monitor growth, water, and nutrients. Science and engineering sustain life beyond Earth. Every meal demonstrates adaptation, planning, and creativity. Space farming transforms biology into a survival tool, blending science with daily human experience. Chapter 91. Microgravity affects human perception. Objects float and movement feels different. Colonists adapt through practice and specialized equipment. Science teaches how the body adjusts to new conditions. Every task, from cooking to repairing, becomes an exercise in skill and adaptation, showing humans can master even radically different environments with patience and ingenuity. Chapter 92. Space habitats may use magnetic shielding to block radiation. Colonists live safely under protective fields while exploring outside. Science ensures both health and equipment durability. Every day demonstrates the power. Chapter 93. Artificial intelligence will plan daily schedules. Task management, energy use, and maintenance are optimized. Humans focus on decisions and adaptation. Science turns data into survival. Every plan improves efficiency, showing how technology and human judgment combine to maintain life in alien conditions. Colonies become symphonies of biology, engineering, and strategy. Chapter 94. Ice on the Moon and Mars provides critical water. Colonists extract it carefully using robotics and filters. Science ensures safety and efficiency. Every leader supports drinking, farming, and oxygen production. Water becomes a lifeline, turning extraction into both survival and exploration, proving humans can utilize natural resources intelligently beyond Earth. Chapter 95. Space medicine is proactive. Wearables monitor vital signs and AI predicts illness. Colonists perform guided treatments remotely. Science ensures health in isolation. Every diagnosis and procedure merges biology with technology, showing humans can maintain well-being in environments where conventional care is impossible, combining foresight, innovation, and vigilance. Chapter 96. Hydroponic and aeroponic farms recycle water and nutrients efficiently. Colonists harvest vegetables and herbs in controlled environments. Science turns biology into survival tools. Every meal demonstrates human ingenuity and adaptation. Space colonies prove that life can be sustained through careful planning, technology, and creativity, turning daily nourishment into a testament of survival. Chapter 97. Martian dust storms challenge colonies. Habitats must be sealed, robots protected, and air purified. Colonists adjust routines to survive. Science ensures safety. Every storm teaches adaptability, planning, and respect for environmental forces. Life on Mars combines caution with exploration, showing that survival is a continuous process of learning and preparation. Chapter 98. Energy management is critical. Solar panels, batteries, and supercapacitors power life support. AI predicts demand and adjusts supply. Colonists optimize usage constantly. Science ensures efficiency. Every kilowatt-hour matters. Space life demonstrates that energy is currency, turning physics into practical daily decisions that sustain life in harsh, distant environments. Chapter 99: Asteroid Resources Support Colonies. Metals, water, and fuel are harvested using robotics. Humans supervise remotely. Science turns exploration into practical survival and economy. Every mission blends technology, planning, and curiosity. Colonies rely on these resources for expansion, proving that humans can thrive far from Earth using knowledge and ingenuity. Chapter 100: Space Exploration Redefines Humanity. Colonists adapt to gravity, radiation, and isolation. Science, technology, and biology converge daily. Every achievement demonstrates resilience, creativity, and survival. Living beyond Earth transforms how humans understand themselves and the universe. Humanity's journey into space is only beginning. From building colonies to harvesting resources and surviving alien worlds, the future is full of possibilities. Every fact we explored today shows how science and creativity shape our destiny among the stars. The question is not if, but when we will truly become a multi-planet species.